Say again? Are there blocks right there? There's one right there. On the desk. Tyler, it's on the windowsill.
You said it was a pen or you said it was a box.
No, I literally said there's a box on the windowsill. Alright, listen. Linear and exponential functions. They're the foundation for what we're going to study when we talk about quadratics, when we talk about cubics, when we talk about quartics, quintics. Exponentials are the foundation for when we talk about logarithmic functions. They're foundations for square root functions. Like, we got to know this. And I get it. For some of us, we're thinking that we have not seen these things before. However, I promise you, if I go talk to your teacher, they're going to be a little frustrated that we don't remember it. And so I'm not going to, I will say this, regardless of whether you think you learned it last year or not. We've spent 4 days just on linear versus exponential. And on top of that, we have multiple mathematical representations. We got to be able to think with these things. And you got to know 2 equations. You've got to know 2 equations. What are the 2 equations that you have got to know? F of x equals a times b to the x and mx plus b. Which one is which? The bottom one is linear. The top one is exponential. Which is why for the last 3 or 4 days in a row, I have said, what is the very first thing you need to do no matter what? Well, before you can write the formula, you got to know what? You got to know the type of function. And I don't care how you identify the type of function, you got to know the type of function, and then you got to write out that formula. I need you to make sure that you know your equations and you know which one goes where. And this is why I keep trying to break it down into making sense out of which type of function has which rate of change, which graph, all that stuff. So we're going to go over this demonstrating understanding. We'll have to finish going over it after lunch. But I just added all this in. This is not stuff I plan on talking about. Now, hopefully, number 1, we're able to quickly identify that type of function. Because literally, what do we see? A line. We see a line. You don't even have to say straight. You don't need that description. It's a line, right? Linear function. Because there is a line. And guys, let me also clearly say this. I get that it's harder for some people than it is for others. That's okay. What I'm not okay with, and the reason why I'm a little irritated, is because we started out really strong holistically as a class, everybody thinking and engaging and trying to make sense of these things. But the last few days with this stuff, I have a handful of us who have been working hard to try to understand it. And I weirdly keep seeing people walk across to other groups to socialize, not make sense out of things. I see people grabbing my presenter remote and I see the laser light all over the place. I see people playing with cards, see people trying to play with dice. That's not trying to learn. You want to get upset about not understanding something or try to learn something in the middle of an assessment, but where was that frustration and that care more than anything else? Where was that care during the learning process? Now, this is a demonstrate understanding. The next demonstrate understanding is going to have some of the same ideas on it. So even if you didn't demonstrate understanding here, if you learn from this and you improve and get better, you're going to be okay. Second, if you do better on the test, let's say you make a 30% on this demonstrate understanding, but you make a 90% on the test, what does your grade become? 90. The 90%. So when we come back from lunch, not grumbling, we're learning. Point blank here. We are not grumbling, we are learning when we come back from lunch.
Stop saying yes, King. Move by King.
How you doing?
But you also, I will say, you need to be able to show me the evidence that you understand where those points are coming from and not just do a sketch. I need you to show me how those points are for that function. Mr. Javi, if you want to continue.
Just use the zoom in and out.
Shows a line.
To do is make sure the SD card's in there.
So, want to be clear with my language. Notice I'm also referring to my mathematical representation. I'm showing evidence of understanding mathematical representations by saying linear function because the graph is aligned. Please notice, you know what two-letter word I have not used that so many of us like to use?
Oh, ew.
It does start with an I. It. It is imprecise. It is unclear. Don't use that. Use clear language to describe the thing that you have. The graph is aligned. Okay? Now, we talked about this multiple times. First, ID the function, or the type of function. After you ID the type of function, what do you want to write out? The equation. And you need to learn these equations. And when I say the equation, I mean the form of the equation. You need to learn these equations, but like there's no way I can give you an assessment without the equation being somewhere on the sheet. Where can you see these equations on the sheet? On the back, right? Like if you look at the back of this, there are two examples of those equations, one linear, one exponential. Use it, take advantage of that. Use that. But you gotta know what these things mean. Okay, it's gonna be hard to learn if you're not facing the board. I might turn it, you can turn the desk around so you can see it. Just make sure this stuff doesn't fall. Tyler, you with me? You focused? Okay, so linear function, because the graph is aligned. So what's the equation I should immediately write down?
Oh, I even meant to.
You gotta know this. We gotta know. As soon as I know it's linear, y equals mx plus b.
Yep.
So whenever you're doing that, look, the x, fx, you put the y equals.
You can put the y equals. I recommend the f of x because it is a function. Remember, f of x just stands for what?
Function. Slope.
The function. The output. And then what's the other letter we can use for output? Y. So like f of x means y, guys.
Yeah.
But when I say f of x, the beauty of it is, if I were to just tell you y equals 7, do you know what your output is, or what your input is? No, your input. Do you have any clue what your input is?
Zero.
B.
For this?
Oh, 7.
Zero.
Well, yeah, 0. Okay, hold on.
The y is 7.
The y is 7, my output is 7. But do you know what your input is?
8.
I was 7.
No, not for this problem. I'm saying, if I told you y is equal to 7, do you know what the input is?
0.
Thank you. You don't know. You're guessing because you don't know. You only know that y is 7. You don't know what the input is. But if I were to tell you f of 3 is equal to 7, what's your input now? 3. And what is 3 mapping to?
6.
So that function notation is way better because it shows us both an input and an output right together. That's why I use function notation. It's not random. It's because it is better long term.
I thought you had my Y intercept.
I got you. But notice I didn't say y, so I just said y equals 7. That's it. All right, so linear function. Like the equation then should help us from here. What do I need to identify? Slope. Which of those letters is slope? Okay. How am I going to get it?
Would be -4.
Are you referring to this right here?
Yes, sir.
Is that my m, guys?
Yes.
Remember, that's on the
But
y-axis.
the m is the x intercept.
No, M is slow.
So first things first, remember, and guys, ask these questions in the future if you have these questions, but I had someone have to ask me, how do I figure out the values? First off, you start at the origin. Am I going to the left or to the right to get to that point?
Low. Wait, oh.
Down.
I'm only going down. Am I going left or right? No, so what is the x value at this point? And I'm going down how far?
4 times.
So down and 4. The next clear point is right here.
Yes.
To get to that point, I'm going to the right.
Yep.
How far?
Forward.
So my x is,
Forward.
and what am I doing from there to get to this point?
Down. Q.
That's it. I'm counting. 1, 2, 3, 4, 5, 6, 7, 8 is my x, and up to, so y is positive 2. We gotta know how to identify points, we gotta know how to graph points. Okay? Fix it.
Fix it.
Gee willikers.
Dang, gang.
Todd dropped his phone. Which I don't know how he did that because his phone's supposed to already be up. So, M is my slope. How do I calculate that slope?
Divide. Wait, no.
I am going to divide something.
Oh, 2 over 3. I mean, 3 over 4. Wait, huh?
How do you get there? How do we calculate slope?
Oh,
Oh, Riley, run.
Rise divided by run,
Yeah.
or
change the white.
Change the Y, change the X. It would be cheaper.
guys, listen. Logic matters. If you know the equation and you just say, hey, there's M, use that to help you get there. You got to know how to calculate M. That is a formula, a thing you got to know. Cameron, you better run like the wind bullseye. We got some math to learn. You got some questions that we need to answer.
Yes, sir.
All right, slope is change in y divided by change in x. That's the way I do recommend it. So I just look at my points. By the way, did I have to keep this as a graph?
Yes.
Whoever said I had to keep it as a graph?
Nobody.
Nobody. I could have made a table here. 0, -4, 4, -1, 8, 2. And so you can see slope pretty easily in a graph, but also like, what's happening to go from -4 to -1?
You add 3.
-1 to 2. Adding 3. 0 to 4.
Add 4.
Notice that's exactly the same. If I were to graph this here.
Oh, wow.
Oh wow.
You get 4.
Notice my change in y is,
My change.
what is my change in y though?
Oh, my output. Wait, what you mean?
Oh,
Oh, you
oh no, 3 is your change in
I was
Y.
gonna say, there's y,
Oh,
right?
that 3.
So my change in y is here
Sure,
at
change in Y.
3. What's my change in x?
4.
4. Notice that's the same as my rise, 3, divided by my run, 4. Yes.
That's amazing math.
Wild. Huh?
1 plus 3.
What?
Like 2 and the plus 3.
The 2 and the plus 3.
Yeah, well, that wouldn't even. Only the next 1 plus 3.
Right. It's different going backwards. It's the inverse. 2 minus 3 would be negative. But this is why we always want to go left to right. You always want to go from a leftmost x value to a rightmost x value.
So 2 is just there, right?
What?
2 is just that.
It's the point. Car, it's this point right here. 8, 2.
I know, I'll do.
But it's not my change. It's just a point. All right.
Gotcha.
So, notice, excuse me, notice how I've labeled everything up to this point?
Yes.
So it's going to be pretty clear what's going in the place of this M.
Evident.
No, what value?
Oh,
3/4. There we
3
go.
fours.
Then what has to come immediately after that 3/4?
Yes. Oh,
X. Don't forget your X. I looked around the room and I saw lots of people missing their X. And I know, like, maybe in the real world you want to miss your X. I get that. But in the equation world, we ain't missing our X's
I got a
here.
question.
What?
What if I miss my 4?
That's kind of important. Fix it, update it, Amber.
I only put 3
Where what? Remember, that was to illustrate why we want function notation.
I'm trying to see how like.
Remember how I had that conversation about if I say y equals 7, do you know what the input is? And the answer is we don't. But if I say f of 3 equals 7, the input's 3, the output's 7. That was just to indicate why I want to use f of x and not y. Okay. Now, what am I still missing? I'm using my equation to help me.
Oh, you missed your lead.
My b. Y-intercept.
Yep.
I can see that y-intercept either on the graph or in the table. What do we know about y? Every y-intercept that has ever existed.
It's 0.
What is 0?
X 0.
The x, the input is 0.
Yep.
So right here in this table, my y-intercept is -4. Notice I labeled it. Or right here, my y-intercept is -4. Either table or graph, right? The graph and the table are telling the same story from different perspectives. So if you're stuck on the graph, make a table. If you're stuck on the table, make a graph. Think flexibly to help yourself out.
Madison said, what if you're stuck on both of them?
Then we gotta learn. Huh?
It's not basis on that.
Good. Now, one final thing. Oh, so then my b is going to be -4. I've labeled it. That's lots of strong evidence. The last thing I want to point out is, again, this, if I have an input of 8, what should my output be? 2. Let's check it.
Yes.
What's taking the place of x?
Uh,
What am I substituting in for x?
4, 3, 8.
My input is 8. And guys, you got calculators. What is 3/4 times 8 minus 4?
Whoa. That's a lot of.
That's a lot of calculator work. Let the calculator do the work.
You said what again? 3/4?
3/4 times 8 minus 4. Right here, the one.
I got it.
What is it? You mean this 2 right here? 8 is mapping to 2?
Nope.
Just like this point right here, 8 is mapping to 2.
Oh my God.
Guys, that's the equation of a line. Y equals mx plus b. Find your m, find your b. It's 2 values as long as you understand what m and b are. You need to update your understanding. Update and don't just write down. Listen again. Guys, let's make wiser decisions in a second. I will come get it and hand it to you. But right now, I need you to not just write down the stuff I wrote on the board, but you need to make sure you understand how we got there. If you don't understand the how, you don't understand the why, you're going to look at the next assessment and be like, Mr. Kenny didn't teach us. False. I have record evidence, okay? We got to understand why. Ask the questions you need to ask so that when you write down your notes, you can explain it. Yes, DeJuan.
We was only reviewing one question.
Yeah, that was one. That was number 1. No, I'm doing none of the rest.
None of the rest. Well, you're gonna have to learn.
Sorry about that.
Alright, who's still doing updating the notes? Jay, Mike, and Todd? Brady?
Yeah, I'm done. I had no day for you.
Okay.
So couldn't they
You mean this thing that I just wrote?
Can it just be that?
Is that the answer? That's the equation for this one. You need the evidence to get there. Alright, yes, Jay. No, I'm gonna skip that one.
Let's get it. What number 5, number 6? I don't understand.
Picard.
Oh my God.
Have I finished? No, I'm on number 2. Chill.
Yes, sir.
Okay. Number 2. Alright. So Makari, remind me, what's the first thing I need to do to be able to write this equation?
Uh-oh.
Identify the function.
I gotta identify the type of function, right?
Yes, sir.
Don't make it complicated, identify the type of function. What do I got?
Exponential.
Why is it exponential?
You look at 2 and 4, 2 times 2 is 4.
It ain't the
4 times
same,
2 is
yeah,
8.
they divide it out quick.
Okay.
They divide it out quick.
2 things I need you to update your knowledge on. Because anybody who said the constant factor was 2 is wrong.
Indeed.
You're close.
Told you.
I need y'all to pay attention to this. Now, 2 things. 1, could I have made a graph here? Yes. 2, 4, 6, 8, 10, 12, 14, 16. Going by 2s to make my life easy. Watch this. I need you to pay attention to this detail. So -3 maps to 16, -2 maps to 8, -1 maps to 4, 0 maps to 2, 1 maps to 1. Now, if my constant factor was 2, would that graph be increasing or decreasing?
Decreasing.
If the factor was 2?
Oh, increasing.
If I multiply by 2, that number's getting bigger and bigger and bigger and bigger. And what's this doing?
Bigger,
Increasing.
I mean,
You divide them by
I am dividing by 2. But there's a better way to write that for the equation. Okay, so first off, we know what's the type of function.
Exponential.
Hey, if you had drawn this graph, could you have said, hey, that's an exponential curve, so it's an exponential function?
Yes.
Right? So you can create a graph to say, hey, that's an exponential function. Bet, cool. Okay, that's an option. I will point this out, and I need you to pay attention, because I saw a couple of us do this. I saw some people doing this. But what's the problem? It's not constant, right? So I'm going to pivot, right? Okay, I'm going to pivot. It's not constant. It's got to be what? Multiplying it. And now remember, there's stuff other than multiplication and constant multiplication and constant addition. But, okay, If it is a constant multiplication, as of yet, do we know what the factor is?
Not at all.
So I'm going to multiply by what?
Constant factor.
16 times it.
Remember, if I don't know what something is, I can use a variable. I can use something unknown. And remember, it's not times 2. We just said, if it's decreasing like this, I'm not multiplying by 2.
No.
And that's because, how do we read a graph? From left to...
Right.
So I need to be going from -3 to 1. I need to go this way. That's why a lot of you thought it was times 2, and it's not times 2.
No, no.
Hey, but guys, what do we know 6, because I gotta go this way. What is 16 times f gonna equal?
8.
8. Oh my.
And 16 times 2 is not 8. Use your reciprocal. Well, you multiply by the reciprocal. Oh, by the way, we already said exponential, so what should we have already written?
The equation.
Oh,
The
yeah.
equation, a times b
To the edge.
to the x. By the way, does anyone know what a is just looking at this table? 2. It is the y-intercept, so it's 2.
Oh, I know you actually got no.
Yeah, a is 2. Yes, we want to know it's the y-intercept, but what is the y-intercept? It's 2. Why? Because the input is
0.
0. Hey, by the way, can I look at the graph and see that same exact detail?
Yeah.
Yes, oh my.
Guys, I need y'all to understand, like, we're sitting there freaking out because we can't just look at the table and know the answer, but that's okay. The table and the graph and the equation tell the same story. Use your mathematical representations. That's why the very first thing we did was the bottle and the cork. And then we looked at Roy and Joel going to the pool. Because we need to be able to look at mathematical representations and multiple perspectives of the same idea. Because thinking is the priority, not just memorizing. Yes, I need to know stuff. I need to know the equation. I need to know the rate of change. But thinking is the priority. So 16 times f. Oh, sorry, I just divided by 16, right? So what is 8 times 1/16? 1/2. If you type that into the calculator, by the way, because again, we got calculators, just type it into the calculator. Yeah, 8 times 1/16 is 1/2.
Oh my.
Oh wait, so my y-intercept, my a was, what was my a? 2. What's my b?
1/2.
Here's my equation.
You didn't
I
get it
got
right.
it right, I just mixed it up.
So, update your understanding, master it before the test. Because if you made a 30, which I pray no one makes a 30, but if you make a 30 on this demonstrated understanding, and you make a 70, an 80, a 90% on the test, then your grade becomes a 70, an 80, or a 90. Because I care about you learning it, not getting it right the first time.
Yes, sir. They're always good.
I appreciate you too. Alright, so this is my final answer. Notice I've labeled everything. I've shown logic for how I got my values. It's not random. I didn't just stare and hope that my equation magically came out of thin air. I used what I know to help me get there. Evidence. Like if you saw someone show this work, would you say, yeah, that person knows what they're doing?
Most definitely.
Yeah. That's clear, consistent, and convincing evidence of understanding. Granted, I'm a teacher. I hope that I clearly understand what I'm doing. But, you know, people make mistakes. What are your questions about number 2 before I continue?
Nothing.
Amber, you updated your understanding? You good? Huh? Do you have questions you need to ask? Sure. Kelsey, you good? Alexis? Good? Kennedy? Good?
Always 0. What was no?
I'm talking to Kennedy.
I think so.
Say again.
I think.
Think. Okay. You updated your understanding? Okay. Number 3. Similar idea. Could I make a graph here? Yes. By the way, you don't have to scale by ones. You can use other scales. It's totally fine. But this one's a little bit easier than the last one. What should I see going on here?
A pattern.
We should always see a pattern, but which
Constant
pattern? And be careful, it's not a linear pattern, it is a constant additive pattern, so the function is linear. Specifically, what's happening to my x?
Add two.
Then on the
Remember,
right.
we're getting
you add
closer
five,
to
subtract five.
0.
Subtract five.
Because if you type in -12 minus 2 in the calculator, you get -14, not -10. Remember, if you're looking at a number line, you read from left to right, and so to go to the right, you're adding. Plus 2 is -10. And here's what's happening to my y. So,
I started from the bottom, that's about
but you always move from left to right.
So that's how I started at the top right.
Not necessarily. We went from the most negative to the most positive, or towards the positives.
Gotcha.
You always go from left to right, so the most negative towards the positives. That's the way you always want to go. All right, type of function then. Linear. What's our evidence?
Cost to add in.
The constant additive rate of change.
Because what shows a constant additive rate of change?
The X value, or the input,
Table.
or the table.
Ooh.
Table shows a constant additive rate of change.
Yes.
All right. So Kalia, as soon as I say linear constant additive rate of change, what am I going to write down next?
The equation,
Yeah, what's that equation?
f of x equals.
Why, you talked yesterday?
Yes, Ricard, he said her name.
F of x equals -5.
Right.
Oh, you mean the actual derivative?
Yeah.
Oh, f of x equals a times b plus x, yeah.
Right, this is linear.
Hold on,
It's linear.
Where, are we doing
Linear
linear?
is mx plus b.
Exponential.
So we need to be careful. Linear is mx plus b. Also, don't forget, linear has what type of rate of change?
Additive.
Constant additive. And what's happening between my slope and the x? They're
They
being
multiplying.
multiplied because multiplication is repeated addition, right? This exponential with a times b raised to the x, that exponent is showing repeated what?
Multiplication.
An exponent is repeated multiplication, right? So we use an exponent with repeated multiplication. So, now I need to find my things. I need to find my m, I need to find my b. So Tyler, do you remember how to find that m, how we calculate it? No, so we need to write this down because we should already have this on number 1. Jamie, help me out. How do we find my m? Rise divided by run? Now, I just want to point this out.
Ain't it changing y over changing?
I was just saying, so when I look at this table, do you see a rise and a run?
No.
Ish. If you understand rise and run, ish. Now, could I make a graph to clearly see it?
Yes.
Yes, but if I'm talking about rise, what is changing with a rise?
The Y.
Why?
We're changing
And
it.
if I'm talking about the run, that's the change in my x. Now I can clearly see what's my y changing by. What's my x clearly changing by?
2.
Oh, man, I got my m. Sweet.
Hey,
So look at your work up to this point and see if you need to update anything.
I think I did that one, guys.
Yeah, we're doing it. Alright. So Brady, what do I still need for this equation? What did we just identify?
The slope.
The m, the slope. So what do we still need?
We need the X.
Come on, look at this equation.
I mean, we
We
need
got
the
the
B.
m. What do I still need?
We need the B.
We need the b.
Yes. The B.
That's it. I just need the b.
Yes, sir.
And what does that b stand for?
Minus.
Okay. So we need to make sure that we understand where this y is. No, that's the change in y is -5. Just to make sure we remember this, because if I have a graph, it's easy. The y-intercept is on the what? The y-axis, right? I don't have a graph though. Well, one, could I have made a graph?
Yes.
Yeah, I don't feel like it though, I'll be honest.
It more than likely would have been 0.
None of us do.
But what do we know about every y-intercept that's ever existed?
It always has zero, it always starts
Zero
zero.
X.
The x is 0.
Yes.
And I don't have that yet. There's no x of 0
You
up
gotta add
here.
two, negative 2 and 0.
Okay, so I can add 2 here, right?
Well,
That gives me negative 2 minus 5 gives me 0, so I'm done, right? Negative 2.
What you did next? Now you did it one more time. That's why.
Oh, that's a y of 0. You're right. That's not what I want. I want an input of
zero.
0. So I need to add 2 again. Negative 2 plus 2 is
What?
0. If I add 2, I need to subtract 5.
Oh my God. We solved the equation.
Well, you don't really solve equations. We found the values.
You find the values of equations.
We wrote the equation. Let's say it that way.
Okay.
There we go. Solve has a very specific meaning in mathematics. If we say the word solve, we mean to maybe solve a word problem, but really we mean to find what makes the equation true. We're not finding what makes the equation true. We're writing an equation for the function. No, I want us to be precise with our language so that when we get to the ACT, we look at it and we say, oh, they asked me to solve here. That means I need to find what makes this equation true. Because the only way that the ACT, the only way that any mathematician ever means solve is find what makes the equation true. That's what the word solve means. So we have to be precise with our language. If not, that's when we get confused later. Remember, I need an input of 0, so I just kept adding 2 until I got to an input of 0.
First thing was 2 plus negative.
So negative 4 plus 2 is negative 2. Negative 2 plus 2 is 0.
So you always start at the bottom, right?
I get to 0.
Right.
Because your input has to be 0. Okay? Make a note to yourself that you have to keep the table going until you get an input of 0. Huh? You gotta keep it going until you get an input of 0. It doesn't matter which direction it is, Picard. Like if I had this, notice I need to get to an input of what, Picard? What input do I need to get to?
0.
So I'd have to go this way to get to 0. So 4 minus 2 is 2. 2 minus 2 is 0. And so if I'm adding 3 going this way, I'm going to go backwards 3. And so there's my y-intercept. I've got to get to an input of 0.
We all put the
When you
pen.
said it was so.
Huh?
Oh, you talking about?
I was explaining to Bakari why I keep saying the input has to be 0. Because it's not going down, it's not necessarily going up, it's getting to an input of 0. Alright, number 4. Hopefully this one jumps out at us. I'm not going to write this down, I'm going to talk through this one. What type of function are we dealing with? Exponential. Right? Type of function, exponential, because the graph is a what?
Exponential curve.
Yeah, as soon as I see that graph, it's an exponential curve.
Yes.
That is literally the name of that curve. So type of function, exponential, because the graph is an exponential curve.
Yes.
That's it.
Crazy.
Okay. So as soon as I know it's an exponential curve, Cameron, what am I going to write down as soon as I know that it's exponential? The equation. What is that equation, Cameron?
It's on the board, Cam.
Kevin, it's literally on the board.
It's the top one.
You said it's exponential, right? Guys, we got to memorize that.
Yes, sir.
Remember, I think I talked about it with the stats unit. If you need to, make flashcards and put your key terms on there, put your equations on there, and do flashcards. Write it out over and over again. You can read it. Read it. If you need to watch a video of me explaining it, watch a video. But we got to know the equations. We got to know these terms. All right, Addison, do you know any part of that equation, like, right away?
The y-intercept?
Oh, the y-intercept. What is that y-intercept?
What, 2?
Now, when you say the y-intercept, are you referring to this b right here? Because it was b in the other equation, right?
Yeah.
So the b is 2?
No, it's the A.
The a. So be clear and be careful with that. A is 2. Remember, this has the exponent indicating that b is being repeatedly what? Multiplied. That's my constant factor. Man, without having to do too much work, I already have a. Sweet!
Preacher and sing.
I do what I can. You don't ever actually want me to sing. Ever. So listen, the most common mistake at this point, I guarantee you, several of you have, that B is 4.
Oh, how did you know that?
Because it's the same mistake that we always make. Because what you did was, you went from this point and you went up 4 and to the right 1, but notice with that, I'm adding, aren't I?
Oh, yes.
That's an additive idea, but this is exponential. I need a multiplicative idea.
A factor of 4.
That brother-
It's not even a factor of 4 though. What's a representation that I could create to see that factor? A table. Guys, if we convert this to a table, these are my points. All I have to do is label them, and then I just put it into the table. 0, 2, 1, 6, 2, 18. Notice I'm not multiplying by 4. What am I multiplying by? 3. Done.
You still haven't figured out X.
It's a variable, dude. It's my input. It can change.
Oh yeah, you're right.
I know. Thank you. I appreciate the thought.
What
though.
about the F?
It's a good idea. Remember, guys, all I need to find are m and b for a linear function, a and b for an exponential function. What? I mean, you can. You don't have to. I mean, if you recognize that's times 3, you don't have to do that. 2 times f. 2 times f is equal to 6. What does f have to be? You can, but f is 3. I hope we recognize 2 times 3 is 6. 6 times 3 is 18. Yes, ma'am. You better run like the wind because we're about to cover the graphing and tables. Yeah. But we got 6 minutes left, and I got to go over these last 2. Now, I will say this one, I'm recording this too. Hey guys, 2, I already recorded and did a screen recording of going over this for first block. I took it off at YouTube, but I'm about to put it back up. So you can find that information there. We had the same demonstrated understanding, I guess 4 days ago in there, maybe Thursday. All right, number 6. What should we recognize about this function? Instantly.
It's exponential. I mean, no. Yeah, it's exponential.
Here.
Wait,
Which one is it?
Exponential.
I was saying, it's got a variable in the what? Exponent.
Exponent.
Okay, so we got lots of ways that we can tackle this, but I will point out, does anyone know anything about this exponential function, like, right away? Nothing? I was like, I got a y-intercept, don't I?
I think so.
Alright, because I have such large numbers, I'm going to rescale my axis here. You don't have to. I'm just taking advantage of this. So, the y-intercept is 6. Do you know how to get the rest of these points, though?
No, you have to do 6 times 2/3.
Oh, 6 times 2/3. What does that give me? It gives me a 4. Notice, I can also make this table and show this. Times 2/3. So the next value is 4. So 1, 4. And I can keep it going. 4 times 2 is 8. Divide by 3, so 8/3. That's a little under 3.
Yes.
I can keep it going. Now, I would also go backwards a little bit. Because I'm going backwards, I'm not going to multiply by 2/3. I'm going to multiply by the reciprocal of 3 halves.
3 halves.
So you can keep that going if you want. Sorry, I'm going somewhat quickly, but we want to get out of here on time. But we see an exponential curve.
Yes, sir.
So, took my points in the table, and I graphed them.
Yes.
That's probably what I would recommend doing.
For everybody?
I would.
Hold on, what's that? Wait,
Yeah, we get 27 minutes. Half.
I just,
Well, I'm going to show you 2 things. 1, I went backwards, so I used the reciprocal. But 2, hey guys, what's a word I keep using for these x values time and time and time again?
Inputs.
Wait, so I could just, I don't know, substitute 1 in?
Yeah, she could. Yes, she can.
And I would get 6 times 2/3 to the first. Can someone type that into a calculator really quickly?
Yeah, I got tried.
You said do what?
6 times 2/3 to the first.
I got 4.
My calculator.
You got 4? You mean just like this 4 that I have right here in the table?
No, that's amazing.
That's amazing. Guys,
Yeah, I got 4.
substitute inputs in, get outputs out. It's going to tell the same story of using the y-intercept and the constant factor. Huh? No, I need you to turn it in so I can score it. I'll give it back to you tomorrow.
You get
Score.
For what?
Good. Did you just say score?
Yeah, I'm scoring it. It's to demonstrate your understanding.
I want to study this at home.
I don't really care.
Yeah, I'll give it back to you.
Oh,
I
Okay?
got a test on this though.
Yeah, that's why I'll give it back to you
So
tomorrow.
where's the test?
Not until later. Okay? Hey guys, excuse me. 1, I'm not done even with this question. 2, I still need to look at number 6 really quickly. So, notice I can substitute -2 in. And if I type this into the calculator is going to spit out 27/2 because that input in gives me this output out. It's all about inputs and outputs. That's the biggest thing.
Mr. Kenny, you did number 6.
You skipped 5.
Oh, I skipped 5?
Y'all,
Dang.
So that was number 6 we said.
Sorry.
good job, Mr.
Just
Kenny.
put an arrow backwards. I don't know how I missed. Oh, that's how. There you go.
You're tripping, Mr. Kenny.
You're tripping. All right.
Oh.
Number 5.
Linear.
We should recognize linear.
Yeah, linear.
Now notice it's not mx plus b. I had it switched around, but you can easily flip it.
It'd be plus MX.
What is my change in y?
-2.
What's my change in x?
3.
What's my y-intercept?
-2.
Notice I've got evidence now. So down 2 to the right 3, or up 2 and to the left 3. And so I can keep this going using my rise divided by my run. But also, I can use this in a table because my input of 0 gives me an output of -2. And what's happening to my y values? What's happening to y?
It's subtracting. What you adding?
I'm subtracting by 2. What's happening to my x?
You adding.
And I can keep that going all day long. I can go backwards.
Oh, that makes sense. Yeah.
Oh, that makes
Okay, so quickly update whatever notes you need to. Put your demonstrating understandings to the center of the group.
I love mine.
Update your understanding. I cannot make that clear enough.
Free little baby, man.
Look, baby, what's up?
No.
By the way, don't forget, you've got those prayer models with lots of check your understanding questions. You got lots and lots of practice to practice with these, with answers, with solutions online. Mr. Hodgson, can you grab the cards that are on all the desks for me real quick? These cards, can you grab those for me real quick?
Kenny, I'll be there.
Thank you. Sweet. Was that including the ones I had up?